Hey everybody, welcome to this week's recording for week number 5 for the Community Weight Loss Challenge assignment. This week's assignment is going to be a little bit different. It's going to go from this week and span into next week. So for week number 5, we have a quick overview of something called t-tests, and we're going to take a look at 3 different t-tests along with 2 other statistical tests, chi-square test and the McNamar's test of categorical differences. So we can just hop right in and start looking at our assignment here. So I have my patient weight loss data set. Just as a reminder, like I like to mention every week, I only have 110 cases in my data set, where your data set should have 250. So the answers and results that you see in the recording you should not use, but the steps into getting the answers from your data set is exactly the same. So let's take a quick look at our assignment here. And jump right into question number 1. Question number 1 asks, is the patient's T1 weight measurement statistically significantly different than the mean weight of all people in the Tri-County area of 201.27 pounds? So basically what we're trying to do is determine if our patient sampling of T1 weight measurements can be generalized out to the rest of the population that we're trying to take the results from this study and kind of generalize it outwards to. And we would do this by running something called a one-sample t-test. So to run a one-sample t-test, you'll come into your SPSS, then go into Analyze and Compare Means. And then from the Compare Means, you'll see that you have all of your t-tests here. So in this recording, we're going to be looking at the one-sample t-test, the independent samples t-test, and the paired samples t-test. So for question number 1, like I mentioned, we're going to run the one-sample t-test. Bring this over here. And for the one-sample t-test, this is what we were looking at in last week's 4 assignment. But this one we're going to be doing something a little bit differently with. I mentioned in question number 1 here that we're interested in comparing the T1 weight measurement to a population mean of 201.27. So this is an important piece of information because you're going to want to enter that in this test value field. 201.27. All right, so now that we have told SPSS what our population mean is, let's go ahead and add in the T1 weight measurement to our test variables, because this is the dependent variable that we are interested in running our test on. And for the t-tests and pretty much everything in SPSS, it is already defaulted to a 95% confidence interval, or a p-value equal to 0.05, which is what we're expecting, and is fairly standard. So we do not need to do anything in the options menu for this test. We're just going to go ahead and click cancel. So again, we have our weight T1 and our population mean. We'll go ahead and click OK. And we have our output here. So we have some descriptive statistics of the weight T1 variable. So I have 110 patients in my sample population here. The mean weight is 178.17 pounds with a standard deviation of 29.56 pounds. So down to the bottom here, this is our actual results of our t-test. So we have the T1 variable. We're not going to be looking at the actual t-value or the degrees of freedom. The piece that we're most interested in is the significance value, and for mine, the significance value is 0.000, which just means that P in this situation is far or very less than 0.05. It doesn't specifically mean that the p-value is 0.000. It just means that the p-value is so small that SPSS just rounds it to 0.000. So in this situation, because my sig value is less than 0.05, that will mean that my mean of 178.17 pounds is statistically significant, than our population mean of 201.27 pounds. So that is question number 1. Question number 2. Did the intervention lead to weight loss in our sample? And this is where we're going to run the paired samples t-test. The paired samples t-test allows us, if the data is structured appropriately, allows the participants to act as their own controls. And since none of them had the intervention prior to this study, which for weight loss is a little bit different, but all of the patients started at the same time and all of the patients ended at the same time in regards to this intervention or weight loss challenge that we were doing. So in our data, we can see that we have weight T1 and weight T2 in the same row here, which means that for patient number 99 in my data set, I have the T1 and the T2 in the same row, meaning that I have a direct comparison and I can run a paired sample t-test without needing to do too much data manipulation to get that test to run appropriately. All right, so let's go ahead and run that paired sample t-test up in Analyze, Compare Means, and we're going to run the paired sample t-test. So I already have it filled in here, but I'll just reset it real quick, because the easiest thing to do with a paired sample t-test and trying to get this whole setup to work right is to actually drag these variables into the correct spots instead of double clicking like we've done most of the time. If you start double clicking, you're going to end up with a bunch of different pairs and things kind of just get a little messy kind of quickly. So my first variable in the pair here is going to be the T1 weight loss. The T1 weight, which I'll drag into variable 1. And the second variable is the weight at T2. I will bring that over here. And we have our pairing of our continuous variables. So again, the only option that we have with our paired sample t-test is the confidence interval, which we're going to leave at 95%. And we will click OK to run our paired sample t-test. So with the paired sample t-test, we get a couple more tables than we do with the one sample t-test. We still get our paired sample statistics. So these are a couple of descriptive statistics. The weight at T1, again, is 178.17 pounds. I have 110 patients with a standard deviation of 29.56 pounds. And then in weight T2, my mean weight is 169.94 pounds. Again, 110 patients. I did not have any dropout or leave the intervention or the study, and having a standard deviation of 28.92 pounds. All right, so we're not going to be talking much about correlations, so you can just skip over this table for right now, but this would show this table basically just shows a correlation between the data if we were to do a scatter plot of this data. you will see that there is a linear correlation, and that correlation is significant. But again, the piece that we are interested in is down the bottom here, the paired sample test, looking at pair 1, weight T1 compared with weight at T2. Coming over to the end, we have a significance of 0.000 again, meaning that the weight at T1 is significantly different than the weight at T2, which is good. And we can see that we have a mean difference of 8.23 pounds, something that you can also calculate here if you so choose. But we can see from this table as well that the mean weight at T1 is higher than the mean weight at T2, meaning that we had an overall weight loss of all of the patients that are in the intervention study. And that mean weight loss of 8.23 pounds is, in fact, a statistically significant weight loss. Right. Moving right along here to question number 3. Is there a difference in bone density between males and females? Right. So this one is a little bit different because now we're going to look at a comparison between something called a dichotomous categorical variable and a continuous variable being bone density. So a dichotomous categorical variable is a variable that can only have one of two values. These are typically shown as 0 or 1, but can be any two values so long as the entire data set, that variable only has two values. So if we go and look at our data set real quick, and we will run just a quick frequency on the gender variable just to make sure that the only things that are here are two values. Over here, patient gender. I'm not particularly interested in any statistics or anything on this one, so I'm just going to run a simple frequency table. Click OK. And yes, so I only have two valid values in my data set, male and female. And going back to my data set here, I can see that I have value labels, 1 being male and 2 being female. So I know that anytime I see a value of 1 in this data set, this is a male patient. Anytime I see a value of 2 in this data set, that this is a female patient. Some other examples in this data set that are dichotomous categorical variables are the 2 smoking ones. So we have an indicator for smoking status of 0 or 1, and those fit the bill of dichotomous categorical variables. Cool. So let's go ahead and run for this one an independent samples t-test. Even though that these are coming from the same data set, the gender being used as the grouping or the categorical variable, patients will only belong to one distinct separate value. There's no indicator in this data set that a patient transitioned from male to female or female to male, and that all of the patients in this data set stayed the same gender through the entire intervention weight loss study. So we will go up to Analyze and Compare Means, and go ahead and run the independent sample t-test. Over here. So our test variable, so this is the dependent variable. And in this situation, it is the continuous bone density variable. And we have our grouping variable, which is going to be the patient gender. And now you'll see here that SPSS would like to know what the two values are that you would like to compare. So in this situation, we have already determined that the values in our data set are 1 for male and 2 for female. So let's go ahead and click on Define Groups. And we will tell SPSS that group 1 is equal to a value of 1, and group 2 is equal to a value of 2. And click Continue. So now we see gender 1 and 2. So this is telling SPSS to compare, to run this independent sample t-test with regards to gender and the two groupings being a value of 1 and a value of 2. So again, I will just show you that our options for our independent sample t-test is only, again, the confidence interval, which we will leave at 95%, or a p-value of 0.05. Click Continue, and then click OK. So we have our statistics here. So we have the male and the female, and we have a mean bone density of 1.06 and a mean bone density of 1.05 for females. And then we have the results of our independent samples t-test here. So the important piece to look at first is this Levine's test for equality of variances. This is a statistical test that will tell you whether or not you can pull the p-value from equal variances assumed or equal variances that are not assumed. And I cover this a little bit more detail in the lecture, or the lecture slides, I should say, so I'm not going to spend too much time explaining it right now, with the exception of what the significance value actually is. So when we look at this one, the significance value is a little bit different than what we would kind of typically look for. So I have a sig of 0.365. So we can say that if the sig results of the Levine's test is not significant, so that would be a p-value greater than 0.05, which we have, we will assume that the variances are equal. So in interpreting this independent samples t-test, I'm going to pull my sig value from the first row here, equal variances assumed. So the p-value for my independent samples t-test is 0.014, meaning that I have a statistically significant difference in bone density in my population between patients who are male and patients who are female. So if, on the other hand, if my sig value for my Levine's test was 0.001, meaning that my p-value was significant for my Levine's test, I would look for my answer in the equal variances not assumed row, meaning that this p-value or the sig for my t-test for my independent samples t-test here would be 0.013. Again, my data set is kind of small, so I'm not surprised that these two p-values are fairly close together, but in either situation, my independent samples t-test came back with a statistically significant difference in bone density between male and female patients in my data set. Question number 4. Was there an overall difference in BMI category before and after the intervention? So I want to talk about question number 4 and question number 5 at the same time because they are asking fairly similar questions, but there is one significant difference between the two questions here. So in question number 4, we are looking at a categorical variable pre-test and post-test, and we are doing the same thing in question number 5, the smoking status is a categorical variable, pre-test and post-test, T1 and T2. But the one significant difference between the two variables is that the BMI category is made up of 4 or 5 values, whereas the smoking status is a dichotomous categorical variable, again, meaning that the only values that smoking status will have are either 0 or 1, whereas BMI category can have a range of values. So let me hop back into my data set here and go over to BMI CAT T1, BMI CAT T2, and I can see here that I have 1, 2, 3, 4, so at least 4 values, right from the first 20 or so cases, and then same thing with BMI category T2. I see 1s, 2s, 3s in here as well. So that tells me that BMI category T1 and BMI category T2 are just categorical variables, and they're not dichotomous categorical variables. Looking over at the smoking ones here, smoke T1 and smoke T2, I can see right here that the only values I have are 0 and 1. And again, to confirm that, I can run the frequency table for smoking status here, as well as the 2 BMI categories. So I can see smoking T1, the only valid values are 0 and 1, and same thing for smoking T2. And then for BMI category T1 and T2, I have a value of underweight, normal, overweight, and obese, most likely being 1, 2, 3, and 4 in my data set. And the same thing for T2. So again, the big difference between the smoking status and the BMI category, while they are both categorical variables, the smoking status is dichotomous while the BMI category is not. And that's a significant difference to keep in mind, because the plain categorical variable, so the BMI category, we're going to run something called a chi-square test, and the chi-square test will test the overall or the generalized difference between T1 by T2, and that will make sense in a minute when I show it to you. Whereas patient smoking status T1 and smoking status T2, being dichotomous categorical variables, will run something called a McNemar's test, and the McNemar's test is specifically used to test a difference on dichotomous dependent variables between 2 related groups. So again, we have our, it's the one group in general, but we are looking at the differences on those dichotomous variables in a pre-test, post-test design, which is exactly what we have here, looking at T1, which was at the beginning of the study, and T2, which was at the end. So let's start by looking at the chi-square test for BMI category T1 and BMI category T2. To run the chi-square test, we'll go up to Analyze, and we're going to run a crosstab table. And so the crosstab table will show us values that are presented frequency-wise for rows by column. And if we were to put in continuous variables, we would see mean values of the continuous variables by a categorical variable. So first, I'm going to take my BMI category T1 and move that up into my rows, and my BMI category T2 and bring that over here into my columns. So basically what I'm doing is building a crosstab table that will show me the BMI category by BMI category T1 by BMI category T2. So what I need to do here to actually tell SPSS to calculate my chi-square test, I need to click on Statistics. And in my statistics window here, I have the option for chi-square. So it's as simple as checking off that box. And we already know that we, by default, will run at a 95% confidence interval or p-value of 0.05, so I'm not going to make any other changes here. I'm just going to T1 by T2 and just click OK. So I can confirm here that I have all 110 of my cases are valid. And I have my BMI category T1 by BMI category T2 crosstab table here, which will show me that in time point T1 and time point T2, I had one patient that was underweight in both categories. Looking at a different number here, so my normal, I had 62 patients at T1 who were also at a normal BMI category in T2. So the only downside is that it doesn't actually show you the change, which is something that we will talk about a little bit later in the semester on how to actually see the differences between T1 and T2. But for all intents and purposes of running the chi-square test, we are looking at T1 by T2. We'll look down here at our chi-square output, showing a asymptotic two-sided significant difference being significant of 0.000 or a p-value of much less than 0.05. So for my chi-square test, I can say that in general, I had a significant difference in BMI category from T1 into T2. The only thing in this situation that I cannot report is the change in T1 to T2. And if it was a positive change, meaning that I had patients move down BMI categories, or if it was a negative change where I had patients move up in BMI categories. But again, like I mentioned, my chi-square test came back 0.000, meaning that I had a significant difference in BMI categorization in my patient population from T1 to T2. So, question number 5 here. Again, was there a significant difference in smoking status between T1 and T2? And again, like we had discussed a minute ago or so, the smoking status is a dichotomous categorical variable. So we are going to run something called a McNemar's test. And a McNemar's test is something called a non-parametric test. And that's something, again, that I discuss a little bit more in detail on what those tests are and what they are used for in the lecture slides, so I won't take up your time here with that. So I'll choose Analyze and then go down to my non-parametric tests here, and then select my related samples. This is because we are doing a pre-test, post-test comparison. So earlier, like my paired sample t-test, my patient population is acting as their own control, meaning that these samples that I'm taking from smoking T1 and smoking T2 are in fact related together. So let me bring over here my non-parametric tests. So just so that way I have all of the options available to me, I always like to choose this Customize Analysis option. It gives me a lot more control when we get over to the Settings tab, but I'm not going to jump ahead yet. So in my Fields tab here, I am going to go ahead and put in my two dichotomous categorical variables that I'm interested in testing. Oops. I have T1 and smoking status T2, and that is it. So I'm going to come over here next to my settings tab, and I do not want SPSS to run all of these tests, nor to try and guess which test I want it to run. So I'm going to choose this customized test option. And the first one that I have here is McNemar's two-sample test. Enable that, which will also give me the ability to define success. And so this defines success for categorical fields or categorical variables, allows you to tell SPSS which of the values, 0 or 1, or whatever two dichotomous variables, whichever two dichotomous values you have that make up your variable, which of the two in this situation or any situation defines some kind of success. So in terms of my smoking T1 and my smoking T2 variables, getting people from that are self-reported smokers, so a value of 1, to a value of 0 or non-smokers is what in my data set defines success. So I am going to pick this second option here, combine values into a success category, which will allow me to tell SPSS specifically which value I want as my success value. So I am going to tell it that my success value is 0, which again is a non-smoker, and click OK. And then I'm going to leave all these other tests that we're not going to talk about all disabled, and then just run my McNemar's test, and click Run. Right. So when my McNemar's test is finished, I will get an output that looks like this. And this one actually gives you one of the answers to your questions here. It tells you the null hypothesis. So the distributions of different values across smoking status T1 and patient smoking status T2 are equally likely for the specified categories. There are a lot of words here. It can be very simply put as that there is a difference in smoking status from T1 to time sampling T2. So here I see my sig value of 0.000, and SPSS actually tells you to reject the null hypothesis. So again, my null hypothesis is that the distribution values of T1 and T2 are equally likely for the specified categories, again, meaning that patient smoking T1 is fairly equal to patient smoking status at T2. SPSS is telling me that this is not true based on the McNemar's test, and that I should reject that null hypothesis, meaning that the distribution of smokers at T1 is just statistically significantly different at T2 from T1. So I know I just played some word jumble there, so let me repeat that one more time. SPSS is telling me to reject my null hypothesis. So again, my null hypothesis is that smoking status T1 is the same as smoking status T2. Rejecting my null hypothesis means that I have a significantly different smoking status from T1 to time sampling T2. So the last part of your assignment here are just two narrative questions. Do you think the weight loss challenge or initiative was successful? Why or why not? And I'm asking you to make a recommendation to the hospital's community relations group if they should or should not continue this weight loss initiative in the community. So you have all of the statistical analysis in front of you to be able to make these decisions. If there are parts of the analysis that you don't think that we ran, that we have talked about in the past 4 weeks or so, that you would like to try and run to, provide a different piece of information, please feel free and do that. I think that's a great addition to your narrative. Again, these don't have to be very long. 3 or 4 sentences a piece is perfectly fine. But any part of your narrative that needs statistical support, you should be sure to include that, whether it be charts, graphs, tables, anything from your SPS output is perfectly acceptable. So that will conclude this recording here for week number 5. As I mentioned, this assignment isn't due until the end of next week, which is the end of week 6. So I encourage you to do this assignment this week because there will be a smaller second piece of this assignment to come in week number 6. And again, both of the assignments, week 5 and week 6, are due at the end of next week. So if anyone has any questions, please feel free and shoot me an email. I'm more than happy to discuss and help anyone that may be running into some issues. Other than that, have a great week, everybody, and we'll talk soon.